Assalamualaikum warahmatullahi wabarakatuh. I am Nur Kulalatul Ifani binti Azman from School of Biological Sciences. In this video, I would like to present about soda lake. First of all, we must know about soda lake. Soda lake or alkaline lake is a lake on the strongly alkaline side of neutrality, typically with a pH value between 9 and 12. They are characterized by high concentrations of carbonate salts, typically sodium carbonate, giving rise to their alkalinity. In addition, many soda lakes also contain high concentrations of sodium chloride and other dissolved salts, making them saline or hypersaline lakes as well. High pH and salinity often coincide because of how soda lakes develop. Now, we move on to the additional information about soda lake. Soda lakes are often highly productive ecosystems compared to pH-neutral freshwater counterparts. Gross primary production rates are over 16 times the global average for lakes and streams have been measured. This makes them the most productive aquatic environments on Earth. An important reason for the high productivity is the virtually unlimited availability of dissolved carbon dioxide. Now, we will move on to the list of soda lakes. Here, I already list out 6 soda lakes that can be found according to the country. The first picture that's shown here is Bangung So, that is located in India. The second one is Owens Lake, that is located in Los Angeles. The third one is Sambar Salt Lake, that is located in India. The fourth one is Lake Turkana, that is located in Kenya, Africa. The fifth one is Lake Eyasi, that is located in Tanzania. And the last one is Lake Nakuru, that is located in Kenya, Africa. Now, we will proceed to the geology of soda lake. In order for a lake to become alkalic, a special combination of geological and climatic conditions are required. First of all, a suitable topography is needed that limits the outflow of water from the lake. When the outflow is completely prevented, this is called an endorheic basin. The high alkalinity and salinity arise through evaporation of the lake water. This requires suitable climatic conditions in order for the inflow to balance outflow through evaporations. Another critical geological condition for the formation of a soda lake is the relative absence of soluble magnesium and calcium. In Mono Lake, California and Lake Van, Turkey, such precipitation has formed columns of tufa rising above the lake surface. Many soda lakes are strongly stratified, with well-oxygenated epilimnion and anoxic hypolimnion without oxygen, and often high concentrations of sulfide. Now, we move to the biodiversity of soda lake. A rich diversity of microbial life inhabits soda lakes, often in dense concentrations. This makes them unusual productive ecosystems and leads to permanent or seasonal algae blooms with visible coloration in many lakes. The color varies between particular lakes depending on their predominant life forms and can range from green to orange or red. Now, we will move to the ecology of soda lake. The first one is carbon cycle. Photosynthesis provides the primary energy source for life in soda lakes, and this process dominates the activity at the surface. The most important photosynthesizers are typically cyanobacteria, but in many less extreme soda lakes, eukaryotes such as green algae can also dominate. However, it is not clear whether this is an autotrophic process or if this requires organic carbon from cyanobacterial blooms occurring during periods of heavy rainfall that dilute the surface waters. The next one is sulfur cycle. There are two types of bacteria that are responsible in sulfur cycle. The first one is sulfur-reducing bacteria. These bacteria common in anoxic layers of soda lakes. These reduce sulfate and organic sulfur from dead cells into sulfite. Anoxic layers of soda lakes are therefore often rich in sulfite. This also plays an important ecological role besides in the cycling of sulfur as they also consume hydrogen. The second one is sulfur oxidating bacteria. These bacteria derive energy from oxidation of the sulfite reaching the oxygenated layers of soda lakes. Some of these are photosynthetic sulfur phototroph, which means that they also require light to derive energy. The last one is nitrogen. Nitrogen is a limiting nutrient for growth in many soda lakes, making the internal nitrogen cycle very important for their ecological functioning. One possible source of bioavailable nitrogen is diazotrophic cyanobacteria, which can fix nitrogen from the atmosphere during photosynthesis. Ammonia, a nitrogen-containing waste product from degradation of dead cells, can be lost from soda lakes through volatilization because of high pH. Soda lake water can be used widely for industrial purposes. Many water-soluble chemicals are extracted from the soda lake waters worldwide. Lithium carbonate from Lake Zabuye, potash from Qinghai Salt Lake Potash, and soda ash from Lake Natron are extracted in large quantities. Lithium carbonate is a raw material in production of lithium, which has application in lithium storage batteries widely used in modern electronic gadgets and electrical powered automobiles. Water of some soda lakes are rich in dissolved uranium carbonate. Algae culture is carried out on a commercial scale with soda lake water. In conclusion, although soda lake seems to be heard quite terrifying, but it has many usability to others like making lithium batteries to electronic gadgets and algae culture. It is also rich in microbial life that makes the soda lake become productive. I think that's all from me about soda lake, and thank you for watching my video.